Have you ever wondered how thousands of tons of metal can stay in the air and fly? Hello, everyone. Today, I will talk about why airplanes fly. We will explore the main forces and principles that make flight possible. Let's get started. Now, let's move on to the most important force in flight: lift. What is lift? How is it generated? And what factors affect it? Let's explore the principles that allow an aircraft to rise into the air. Now, let's define lift. As air flows around an object, it creates forces on its surface. Lift is the force that acts perpendicular to the direction of the airflow. In aviation, this is known as an aerodynamic force. What is an airfoil? An airfoil is a specially designed shape that generates lift while minimizing drag. The wing is the aircraft component that incorporates this shape to produce the lift required for flight. Now, let's see how lift is generated on an airfoil. Lift is created by a pressure difference between the upper and lower surfaces of the airfoil. When the pressure above the airfoil is lower than the pressure below it, an upward force lift is produced. But why is the pressure lower on the upper surface? To answer this question, we need to apply two fundamental principles of physics: the conservation of mass and Bernoulli's principle, which describes the conservation of energy in a flowing fluid. Now, let's look at the principle of mass conservation. As air flows over the airfoil, the stream tube above the wing becomes compressed, reducing its cross-sectional area. Because the same amount of air must continue flowing through this smaller space, the air speeds up. The greatest acceleration occurs near the front of the airfoil, where the stream tube is compressed the most. This increase in velocity is a key step in creating the pressure difference that generates lift. Now, let's apply Bernoulli's principle. This principle states that as the speed of a fluid increases, its pressure decreases. As air moves over the curved upper surface of the airfoil, it speeds up. Because the air travels faster above the airfoil, the pressure there becomes lower than the pressure below it. This pressure difference creates an upward force, known as lift, which allows the aircraft to fly. To understand aerodynamic forces, we need to consider two types of forces acting on an airfoil surface: pressure, which acts perpendicular to the surface; shear stress or friction, which acts parallel to the surface. Both are measured as force per unit area, N/m superscript 2. The combined effect of these forces creates the overall aerodynamic force acting on the airfoil. Now, let's look at the factors that affect lift. These can be grouped into three main categories: the object, the shape and size of the airfoil; the motion, the aircraft's speed and angle of attack; the air, properties such as density, viscosity, and compressibility. Together, these factors determine how much lift an airfoil can generate. To wrap up these core concepts, consider this idea from John D. Anderson's Introduction to Flight. No matter how complex the flow field or the shape of a body, aerodynamic forces ultimately come from pressure and shear stress acting on the surface. In simple terms, all flight physics comes down to how air pushes on and slides along an object's surface. To conclude this presentation, let's review what we have learned. You should now be able to answer the following questions about lift. How is lift defined? How is it generated? Can lift exist without a fluid? Can there be motion without lift? Which factors affect lift? Which forces are transmitted by air to an airfoil? Thank you for your time. If you found this technical overview useful, feel free to follow our page, share it with colleagues, and like the content. Your support helps us continue creating educational material for the aviation community.